Okay, so I'm gonna do a test review video of all the test review for this unit. There will be one free response question on your test that requires you to use the definition of a derivative. So we're gonna practice that with 1A and B. You can skip C. We won't make you do x to the third with the x plus h. All right, so A is 2 minus 3x. So the limit as h goes to 0, I'm going to do f of x plus h, or in this case it's y. So that's 2 minus 3 times x plus h. And distribute the negative 3. And then minus the original function. You have to distribute the negative. And then 2 minus 2 is 0, negative 3x plus 3x. So then I can simplify the h's, and there's nowhere left to plug in 0, so the answer is negative 3. Okay, B is going to be a bit more work because we have a quadratic. I know the answer is going to be 6x plus 2 because we know the power rule now. So let's prove it. So I have to do the f of x plus h part. I'll do that over here. So I have to square dx plus h, distribute the 2. I'm going to need a lot more space. So x times x times h, and x times h is 2 of them, h times h. And then distribute the 3. All right, so that is the first part of my numerator. I'm just going to start my limit down here. So that it's minus the original function. I have to distribute the negative. You have to write this limit as h goes to 0 until we substitute in the 0. Okay, what simplifies? 3x squared minus 3x squared, 2x minus 2x, and negative 1 plus 1. So then what I can do, I need more space, is I can factor out an h in the numerator. These h's divide. So now I'm left with an expression that has no denominator, so we can substitute in the 0. And our derivative is 6x plus 2, which is what we originally said we know we would get. All right, we did number 1. Use the rules to find the derivative. So for A, the derivative is going to be 3. The 12 becomes the coefficient. Subtract 1 from your exponent. Now, if you don't want to do 4/3 minus 1 by hand, you can use your calculator. We have a negative exponent now. So negative 3/4 x. So when we subtract 1, I'm going to get negative 7/4. Because the problem started with the negative exponent, we can technically leave it with the negative exponent. If you're going to change it, this x to the 7/4 moves to the denominator, and then the exponent becomes positive. Before I can do anything on e, I have to change the radical to an exponent. Now I can find the derivative. And then I have to move the variable with the negative exponent back to the denominator and make the exponent positive. Okay, for f, four times 3/2 is 6. 3/2 minus 1 is 1/2. But then this term has to move to the denominator. And that is our final answer. For g, thankfully now we've got all integer exponents. Makes this a lot nicer. Same thing for f, so this becomes 24x squared. All right, I need more space for I. So before I can even take the derivative, I need to change the square root to an exponent and the fraction to a negative exponent. So now, the power rule gives us 15x to the 4th minus 5/2x to the negative 1/2 minus 7x to the negative 2. You have to subtract 1 from all of your exponents. And now the negative exponents move back to the denominator and become positive. So we have to change j before we can take the derivative. So now the power rule says, but then we're going to move the negative exponent back to the denominator. Find the slope of the tangent line to the graph at the given point. So if we find the derivative and then plug in 2, we still get 3. So f prime of 3, still negative 2. So for this one, we plug in negative 2. We get 2 times negative 2 is negative 4. So I need the derivative, and then substitute in the x value. I get 7. So when I plug in negative 3, that's 5 minus 3 times 9. And you can use your calculator for the arithmetic if you'd like. Okay, find the equation to the tangent line. So first, for all of these x values, I need a y value from the original function. That's 7. And then I need my derivative at 5. So f prime of 5 is still 2, and that's my m. So y minus y1 equals mx minus x1. So that is point slope form. The answers at the bottom are in slope intercept form. So to modify it, I'm going to distribute the 2 and then add the 7. So both of these are correct answers. So let's see. For B, I need a y value. Then I need my derivative at 2. I also get 4. So y minus y1 from the y equals m from the derivative, x minus x1 from the x point. So in C, the y value is 0, the derivative is 0, the x is 0. So y minus 0 equals 0 times x minus 0. That you should simplify and just get y equals 0. Now for D, the y value at 0 is negative 6. The derivative 2x plus 1, so that at 0 gives me a slope of 1. So we get y minus y1 equals m x minus x1. I'm going to simplify that to, this is y plus 6 equals x, so y equals x minus 6. Both are correct. This with the 0 is just extra, so this looks nicer. Okay. The y value at 0 is 4. The derivative at 0 is 0. So we've got y minus y1 equals mx minus x1. So that's y minus 4 equals 0, or y equals 4. Okay, the next page. When the original graph is increasing, that means the derivative is positive, so I'm going to say greater than 0. When the graph is decreasing, that means the derivative is negative. When the graph is constant, the derivative equals 0. Okay, the derivative of this is a kind of function, so let's see. It's going to be constant because I know the derivative is 2. Which is just a horizontal constant line. So the derivative of a quadratic is linear, because if you think about finding the actual derivative equation, you get 2x plus 5. So since the power rule subtracts 1 from the exponent, the type of equation comes down 1. So this is cubic, so the derivative is quadratic. And this is quartic, or to the 4th. So the derivative is cubic. Okay, the graph of the derivative. The slope of this is always negative 2. 9 is a little unique. If I think of the original graph, moves to the right 2 and is this absolute value. So there is no derivative at that absolute value vertex because it's a sharp point. On the right, this is a positive 1 slope, and on the left, if it's a negative 1 slope. So for 10, you can do n deriv, or I know the derivative, now that we know the power rule, is 2x. So I'm going to graph 2x. And get that line. Okay, so for 11, we're given all the information for our tangent line. This is y1, this is m, and this is x1. So there's our equation of our tangent line. Find the slope of the tangent line when, okay, well first I need the derivative. That's 3. So the slope at negative 1 is still 3. 14, graph both. So I'm going to get out my calculator. So in y equals, I'm going to put 4 divided by x, graph it. And then write the equation of the tangent line and graph both. So if we do second program, choice 5 is tangent, and I want it at -2. So I hit -2, enter. Here's our graph. Here's the tangent line. And then you have to round this equation appropriately. That's going to be -x minus 4. Don't put all those decimals. You have the brain, the calculator does not. Okay, find the derivative. Use it to determine any horizontal tangent lines. So that's when the derivative equals 0. And I need some more paper. Okay. So there's a greatest common factor we can factor out of 3x. So each factor equals 0 at 0 and -2. But the question says points. So I need coordinates. Now to get these y values, you have to use the original function. So when I substitute 0 back into f of x, I get 0. That one I can do easily in my head. Then I have to substitute in -2. I might as well use my calculator. And I get +4. So these are the 2 points where the tangent line is horizontal. Oh, those are all answers, so that means I'm done this one. All right, page 31 and 32. Find the derivative. So the domain of a quadratic is all real numbers. The tangent line, well, so I need the slope at -1. So f prime of -1. Let's use the calculator for that. That's -6 minus 8 minus 5. So y minus 12 equals -19, x minus -1. Okay, so find the points where the tangent line is horizontal. So I'm going to set my derivative equal to 0. You could factor, or I give you a nice little hint here. Use your graphing calculator to find where the derivative has x-intercepts. You could also use quadratic formula if you like that. There are no x-intercepts, so none. Because if you use the quadratic, and there's the answer, none. If you use the quadratic formula, you would get the square root of a negative, which is imaginary, so there's no x-intercepts, so we are finished that problem. Okay, 10x minus 4, all real numbers, it's a line. The derivative at 4 gives me the slope. So y minus y1 equals m, x minus x1. This one I can solve easily. I don't need the calculator. So the x value is 2/5. Now I need a y. To get the y coordinate, I have to substitute 2/5 into the original equation. So as a fraction, it is 6/5. Okay, for 3, I can't find the derivative until I change the function to have a negative exponent. So that's -2 divided by x to the third. You can't divide by 0. So the domain of the derivative is when x cannot equal 0, or x cannot equal 0. The tangent line, so the derivative at 2 is negative 2 over 2 to the third. It's negative 2 over 8, negative 1/4. So we get y minus y1 equals mx minus x1. And where does the derivative equal 0? Nowhere. Or none. Okay. For this function, we have to change it before I can find the derivative. So for the derivative, the 1/2 comes down to the coefficient. Subtract 1 from the exponent. The rest are nicer integers. So the final derivative is going to be 1 over 2. And I'm going to rewrite that back as a square root, because why not? Because this 1/2 in the denominator, the power of 1/2 is the same thing as a square root of x. So the domain, okay. In the denominator, the square root of x has to be greater than 0 because you can't square root a negative and you can't include 0. So really, it's just x is greater than 0, not just the square root. The tangent line, so when I substitute 1 into the derivative, let's use the calculator. Well, the square root of 1 is 1, so it's going to be 0.5 plus 3 minus 8. That's negative 9 over 2. So y minus y1 equals mx minus x1. And where does the derivative equal 0? Well, that is totally a calculator 1 because I am not solving that by hand. So we want to find the x-intercepts. I'm going to do second trace 0, left bound, right bound. So the first one is at 0.164. Then I have to find a y value. Now I got to find the x-intercept over here. .63. Okay, so now I have to substitute those values back into the original. That's annoying. Let me do it this way. Square root of x plus x to the third minus 4x squared minus 1. And then I'm going to use the y1 of 0.164, negative 0.698. Then I'm going to do y1 of 2.63 and get negative 8.854. All right, last one. Nope, 2 more, sorry. Before I can take the derivative, I have to change the exponent to a negative. So that's negative 3 over 2x to the fourth plus 3. Oops, this is derivative. So x cannot equal 0 because of the denominator. The slope at negative 1 is going to be negative 3 over 2 plus 3. That's 3 over 2. So we've got y minus y1 equals mx minus x1. And where does the derivative equal 0? I'm going to use the calculator again. Oops. Okay, well, my answer key, I guess, is wrong. So let's find those two spots. Left bound, right bound, guess. So the first is 8.41 for the x value. And it looks kind of symmetrical, but let's check. Yep. All right, so now I'm going to substitute, or I'm going to put in the original equation so that I can use my calculator to get the y values. So that is 1.636 and 8.363. Nope, 4. It rounds up. All right, last one. Oh, and it's a polynomial, thank goodness. Negative 16x to the third plus 9x squared plus 4x minus 1. Domain is going to be all reals. The derivative at 0 is going to be negative 1. So we've got y minus 0 equals mx minus 0. And when does the derivative equal 0? Well, because it's cubic, there's a potential of 3 locations. So let's use the calculator again. To find them. It's kind of hard to see. I'm going to hit zoom number 4 as decimal. It's a nicer zoomed in window. Now I can see my 3x intercepts. Second trace, 0. Left bound, right bound, guess. Negative 0.412. Got to repeat that 3 times, or 2 more times, 3 total. 0.194. 0.780. And then I need the y values. So in y1, I'm going to type the original equation. Then I'm going to go to vars, y vars function y1. Second enter brings that back up, and I can just type in the right x, and I get my 3. Oh, that's going to be 8, 0. Y values. Ooh. All right, end of test review.